Hi everyone! In the previous video, we have introduced the Euclidean algorithm and we have presented examples showing how to launch a Euclidean algorithm step by step. In this video, we will take a closer look at the mechanics of the Euclidean algorithm. In particular, we will try to answer two questions. First, why the Euclidean algorithm always terminates in finitely many steps? Second, when the algorithm terminates, why the returned value is precisely the desired greatest common divisor of the original couple A and B. Actually, both questions are fairly easy to answer. Indeed, recall that the Euclidean algorithm is nothing more than a repeated application of the division algorithm, where each time the current divisor will serve as the new dividend and the current remainder will serve as the new divisor. Also bear in mind that the remainder should be strictly less than the divisor. Applying this important consequence to the first equality, we see that R1 should be strictly less than B. Now, B becomes the new dividend, R1 becomes the new divisor, apply the division algorithm again, we got R2. Hence, the remainder R2 should be strictly less than R1. Keep going, taking R1 as a new dividend, R2 as a new divisor, we achieved R3 as the new remainder. Hence, R3 should be strictly less than R2. Now, repeat this process and keep going. We notice that the Euclidean algorithm will eventually give us a sequence of remainders which is strictly decreasing, where all terms are bounded from above by B and are bounded below by 0. Since the sequence is decreasing, it must reach its 0 at some term, say rk plus 1. By then, the algorithm will finish, definitely. Now recall that when rk plus 1 has reached 0, we will return the previous remainder, rk, as the outcome of the Euclidean algorithm. To see why rk is precisely the greatest common divisor of the original couple A and B, let us distract a little bit from the current problem and deduce a general consequence for the division algorithm. More precisely speaking, assume that A is equal to BQ plus R. What will be the greatest common divisor of B and R? Notice that R is equal to A minus BQ. Hence, GCD BR is equal to GCD B and A minus BQ. And recall we have proved in the previous section, this is precisely equal to GCD AB. In other words, whenever we have launched a division algorithm, the greatest common divisor of the dividend and the divisor is always equal to the greatest common divisor of the divisor and the remainder. Now, repeatedly apply this consequence to the sequence of equalities achieved in our Euclidean algorithm. We see that GCD-AB is equal to GCD-BR1, which is in turn equal to GCD-R1-R2, which is in turn equal to GCD-R2-R3, and we can keep going until it is equal to GCD-RK and RK plus 1. But RK plus 1 is equal to 0, so this becomes GCD-RK 0, and that is precisely RK. This has finished our discussion on the validity of the Euclidean algorithm. In the next video, we will study the efficiency of the algorithm.